Hi everyone, welcome to Vedantu J English. I'm Diksha Kaushal, your chemistry master teacher. So everybody, let me know in the chat box if I am clearly visible and audible to all of you or not. Hello Harshita, then Prem, Sumit, how are you all? Already broken? Yes, everybody. Hello Abhijit. Yes, definitely. So, guys, today we are going to do the last lecture of this chapter, that is some basic concepts of chemistry. We are going to do POAC and law of chemical equivalence. Both are very small topics, right? And these two topics are actually simple. They are not difficult. Like if you say that, ma'am, oh my God, it seems like they are very difficult. But in reality, they are simple topics. But yes, the application, when you see how to apply this, you would actually say, yes, I want to do questions based on this, right? So this is basically, firstly I'll talk about POAC, then we will move towards law of chemical equivalence, right? So in the last lecture, guys, we discussed about empirical formula and empirical mass, and through Abhijit, then Bala, Tripit, these are the students who actually did their homework, right? Rest of them, very few students joined last time and very few students concentration terms. I've already done concentration term, Abhijit. You can check that out on the live session of this particular, and also ask the team to make a playlist of some basic concepts of chemistry, right? Their concentration terms will be added, right? We have already done that. I think the first lecture was concentration terms only, right? Now let us see what was the homework, right? Which of the following cannot be an empirical formula? Now they are asking which of the following cannot be an empirical formula. So which cannot be an empirical formula, guys? Empirical formula must be in simple whole number ratio. So this is 1:6. This is 4:10, which can further be converted to 2:5. So definitely this cannot be the empirical formula, right? Because it is further divided by 2. It is not in the simplest whole number ratio. So answer is going to be B is the correct answer here. Next was, if molecular formula is equals to N into empirical formula, we are saying that if your molecular formula is equals to N into empirical formula, then 1 by N is what? Now students, it's very simple. We are going to ask you in the terms of formulas or mass, right? So what is N? N is nothing but molecular mass divided by empirical mass, right? So molecular mass divided by empirical mass, D is the correct answer here, right? Easy, ma'am? Yes, very good. On Saturday, okay, I did not attend. Okay, Abhijit. Okay, I know that you have watched the recorded version, replayed version of that. So that was good. If you have not watched, if you're not able to attend the live, then at least watch the replay version, recorded version, right? Next is, yes, I think that's it. These were the two questions, right? Okay. Yes. Okay. Now, let us see the next one, that is POAC, right? That is your today's topic. Firstly, how many of you have an idea about POAC? Thank you so much. Thank you so much, Funny. Thank you. So, what is POAC, ma'am? Yes, that is exactly the question. What is POAC, ma'am? Right? How many of you have ever studied POAC, or you have an idea that what is POAC? Let me see that in the chat box. If you have an idea about what is POAC, POAC is Principle of Atom Conservation. Now, this is based on law of conservation of energy, conservation of mass. We know that in law of conservation of mass, we discussed that this is E, this is B, this give rise to C, this give rise to D. Now we know that how come mass is conserved? We know that mass is conserved because atoms are conserved, conserved. See, if the atoms are not conserved, right, then the mass will also not be conserved. It's just that atoms are getting rearranged here. For example, let me give you an idea about it. Like we have H2, right, or we have H2 plus O2 that give rise to H2. Now, this is the balanced chemical reaction, right? Now, why I am writing it, I know that earlier it was H2, earlier it was O2. Now, after rearranging the atoms, earlier it was like this. This was H2, this was O2. Now it has become H2. That means this is nothing but this is rearrangement of the atoms, right? Atoms are being conserved here, right? So that's why it is based on principle of atom conservation. So now we are clear that atoms are conserved, right? That you are clear now that atoms are conserved here, right? Now the next question is, ma'am, POAC is conservation of mass, that we know. In a chemical reaction, atoms are conserved, that we know. Now, if the atoms are conserved, I'm not saying moles are conserved. I'm saying moles of atoms are conserved. Atoms are conserved means moles of atoms are conserved. I can say that here you have 2 moles of atom. 2 mole of hydrogen atom react with 1 mole of oxygen atom to give which thing? To give again 2 moles of, what is this? This is not 2, is it? My bad. This should be half here, right? Yes. Now, if I want to write it, can I write it like this? I'll just write it like this, right? Let's write it, okay? How in the terms of moles of atoms you can write? Can you see that on the left side and right side what we can write here? On the left side and on the right side what we are going to write, okay? So, on the left side it is 2 mole of hydrogen atom. On the right side what you have? 2 mole of hydrogen atom, 2 hydrogen atom or 2 mole of hydrogen atom. So you can say 2 mole of hydrogen atom. That means, can I say hydrogen atom is conserved? Yes. Right? Other is 1 mole of, see, half of O2 means 1 atom of oxygen. Right? So that means 1 mole of oxygen atom, 1 mole of oxygen atom is on the left side, and on the right side also you have 1 mole of oxygen atom. So can I say that this statement is absolutely right, that moles of atoms are conserved? That moles of atoms are conserved. Tell me one thing, if that thing is clear to you, that how I am saying from law of conservation of mass, I am telling you moles of atoms are conserved. Moles of atoms I am talking about. We are going to talk about atom here, right? So now let's see how to apply this, okay? How we will apply the principle of atomic conservation, right? I'll give you a simple example of, let's say, Haber's process. Now, I'll give you the example in such a way so that we don't have to balance. See, both the things in POAC or in law of chemical equivalence, you don't have to balance the equation. That is the best part about POAC and law of chemical equivalence, that balancing is not needed here, right? So we are not going to balance it, right? Now, what we are going to see here is that this is 1, this is 1, this is 1, right? I am not going to balance it, right? Now, this is nothing but we are applying this on atoms. So, one by one, I will apply this on atoms, okay? So, the first atom that I have is nitrogen. So, I'll apply, you will say apply POAC on nitrogen. So, if you have to apply POAC on nitrogen, how will you apply? First is you will apply the number of moles of nitrogen. Here, equate this to number of moles of NH3. In this case, Nitrogen has, N2 has nitrogen. In this case, ammonia has nitrogen. So we will equate the number of moles here, but we will multiply it with this number. Now in 1 mole, you have 2 nitrogen atoms, and in 1 mole, you have only 1 nitrogen atom. So you can write it like this is your POAC application. Simple, easy, right? Maybe in the first go, you will be like, ma'am, what you are doing, right? Let's take 1-2 examples. Trust me, you will find it very easy, right? Now, that is the first thing, right? Now, same way, I am going to apply POAC on hydrogen, okay? Let's apply, right? Apply POAC on hydrogen atom. You have to apply POAC on the hydrogen atom here, right? Okay, everybody. So let's apply POAC on the hydrogen atom here. Ma'am, how without balancing? See, chalo, let's do that. Let's do that. How without balancing? Let's see that. If you balance it, it is N2 plus H2 give rise to NH3. If you balance it, it will be 2 here. No, it will be 3 here. It will be 2 here, right? When you balance, when you try to equate number of moles of nitrogen and number of moles of NH3, it will be number of moles of nitrogen divided by its stoichiometry, number of moles of NH3 divided by its stoichiometry. Isn't it the same result that you are getting here? Isn't it the same result that you are getting here? So, it's not like this method is wrong. This method is absolutely right? But I will give you some questions in which you will not be able to balance that reaction only. So when you are not able to balance the reactions, right, there is a method called POAC which will give the same result that we will have after balancing the reactions. Okay, understood? One thing is we are balancing, we are equating by mole ratio, we are solving, that I told you in the previous lectures as well. Number of moles of N2 divided by stoichiometry, number of moles of NH3 divided by stoichiometry, that is the mole ratio that we got after balancing the equation. And this method is stoichiometry, this method is POAC. In this you equate this, when you apply POAC on this nitrogen, nitrogen is present here and here. So you equate this nitrogen, then you multiply it with here nitrogen. In 1 molecule you have 2, you multiply it with 2. Here in 1 molecule you have this 1, so you multiply it with 1. Aren't you getting the same answer here, right? Okay, that is how it is applied. Right? Firstly, you just learn that how to apply this. Now, if I have to apply this on hydrogen, hydrogen is present here and hydrogen is present here, right? So, firstly, I have to tick mark wherever hydrogen is present. Now, I will equate it left side equals to right side. Now, on the left side, what I have, number of moles of H2. Here I have number of moles of NH3. Okay. Now, I have to multiply it with. Now, tell me which digit I will multiply this NH2 moles. Here you have 2, right? So, it will be multiplied by 2. In hydrogen, you have 2 atoms of hydrogen. Here you have 3 atoms of hydrogen. So, this will be multiplied by 3 and that will become your result. And if you equate it, this is your result from POAC. If you equate it by balancing, you will get the same answer. Number of moles of H2 divided by stoichiometry 3, number of moles of NH3 divided by stoichiometry 2, you will get the same result here. Result is same, students, but you will see it in the questions where to apply POAC, where to apply that, right? Okay. Yes, everybody. Is that clear? Now, next equation is this one. Next is this equation. In this equation, you have calcium, you have silicon, you have phosphorus, you have carbon, you have oxygen, right? All these things are there. Now, I will apply in 3 things, okay? You can apply everywhere. If you want me to apply on all the things. I will apply POAC on all the things. Firstly, I will apply POAC on calcium. POAC on calcium. So calcium, if you talk about, calcium is there in what other molecules? What are the molecules where calcium is present? Right? Abhijit, see, this is 2, right? This is what I am telling you. This is 2, this is 3. This is number of moles will be multiplied by this digit, that is 2. This number of moles will be multiplied by this digit, that is 3. Okay? Right? Now, let's see the next thing. This is calcium and here this is calcium. Okay, 2 compounds of calcium we have. Now I will equate this. This is number of moles of Ca3PO4 twice. This is equals to number of moles of CaSiO3 multiplied by the atoms that are there of calcium. In this, how many atoms of calcium are there? 3 atoms, so it will be multiplied by 3. In this, how many atoms of calcium are there? 1, so it will be multiplied by 1, and this is the answer for POAC. Okay, this is the answer for POAC. Let me know in the chat box, guys, if that is clear to all of you or not. But will you be able to apply POAC? That is so simple. Okay, now let's apply POAC on phosphorus. Apply POAC on phosphorus. So when you have to apply POAC on phosphorus, you have to select the compounds that have phosphorus in it, right? So phosphorus is present here, phosphorus is present here, right? So now over here, how do you write? This is simply you can say number of moles of Ca3PO4 twice equals to, this is number of moles of P4. Now how many phosphorus are present here? This is PO4 twice. So phosphorus is 2 phosphorus is present here, so this will be multiplied by 2. Here 4 phosphorus is present, so it will be multiplied by 4, and this is the answer after applying POAC. Right? This is the answer. Guys, why I am doing POAC? By repetition I am doing, so that those students who are not able to understand in the first go what is POAC, they can do this now. Right? So I want you guys also to answer in the chat box, right? Because this is calcium, we have done phosphorus, we have done. Let's say someone is asking you for silicon. Silicon, this is silicon, silicon is present here, right? Apply POAC on silicon. After that, I'll apply POAC on carbon also. Here now, I'll also apply POAC on carbon on the same page, right? Apply POAC on carbon. Oxygen, maybe you will find it little tough, so that I'll do in the next page. POAC on silicon, that is number of moles of SiO2 equals to, here it is number of moles of CaSiO3. Here you have 1 silicon in 1 molecule, so it is multiplied by 1. Here also you have 1 silicon, it is also multiplied by 1, and that becomes your final answer in this, right? Next is, if you talk about carbon, carbon is present here, carbon is present here, right? So number of moles of carbon atom is equals to number of moles of CO, right? Here carbon is 1, here also carbon is 1. So that is after applying POAC on carbon, right? Okay, easy peasy. Now you are feeling that this is easy. Lecture for atomic structures app, don't worry, that is the next lecture is going to be on atomic structure only, right? Okay, that is clear everybody, that is clear, right? Shall I move ahead? Now let's do apply POAC on oxygen atom, on oxygen. How you are going to apply this? So firstly, let us see how many compounds have oxygen. So this has oxygen, this has oxygen, this has oxygen, this has oxygen. Now see this very carefully. Firstly, I will write number of moles of Ca3PO4 twice. On the left side, I also have SiO2, so I'll write SiO2. Right? Equating it with this, I'll write it here, SiO2. Equating it with the right side, you have number of moles of CaSiO3 addition. Here also you have oxygen, number of moles of CO. Right? Now, in this particular molecule, how many oxygen atoms you have? 4 into 2, that is 8, so we'll multiply it by 8. Here you have how many oxygen atoms? Here you have 2 oxygen atoms, so it will be multiplied by 2. Here you have 3 oxygen atoms, it will be multiplied by 3. Here you have 1 oxygen atom, it will be multiplied by 1. And this is full-fledged POAC that you have applied here. Okay, this is full-fledged POAC that you have applied here. Let me see why students are so less. Huh? Why the students are so less? What has happened? You don't want to study? Let me just see. Now, that is your applying POAC here, right, on the oxygen atom. Now, let me know in the chat box if you are able to apply POAC or not, right? Now, students, let me know in the chat box if you are able to apply POAC or not, right? POAC is clear because now I'm going to move towards the questions of POAC, right? But for that, if you have no idea how to apply POAC, then it will be very difficult to understand the questions on POAC, right? Okay. Yes, everybody. Yes, everyone. Okay. I am waiting for your answer in the chat box. The silent watchers also, you can reply, huh? There is no harm in replying to a teacher who is there to teach you only, right? Okay, there is no harm in that. Nothing I am going to take away from you. I am just asking if that is clear or not. If you can't, if you're so lazy to reply to that also, then I feel pity for myself and I feel pity for you as well, right? I think I feel so sad that I'm teaching you then, right? If you're not like, ma'am is like, throat is blocked, but ma'am is still teaching, right? With all the energy that I have, but still I get no response from you guys, right? Because what you want is, I also know, right? You just want to, that ma'am, we just want to relax, है ना? Ma'am, we don't want to say anything, we don't want to reply to you. Very bad. Even now only 2 students are there. What about others? Yes, Rama Raju is there. Wait a minute. Okay. So, next is, now we have learned how to apply POAC, right? Now we are going to discuss that how to do questions on POAC, right? So the first question here is 27.6 gram of K2CO3, there is some K2CO3, right, was treated with series of reagents. I have no idea how many reagents. There are series of reagents, so as to convert all of its carbon is converted to a compound that is K2ZN3FeCN6, and this is twice. Now, can you tell me, can I balance this equation here, right? Okay, Gokul, okay, Taniswari, yes. So, beta, if you're there now, you please reply me when I ask you something, right? It gets very monotonous for me as well, that I'm teaching you. Just imagine that you are I can't see you, right? It's not like you are sitting in the class in front of me that I'm able to read your expressions. All I can see is your chats, right? If the chats also you are like not replying, not even saying, right, ma'am, if that is clear or not, then what happens is I get demotivated. I don't know whether you're able to understand or not. And I am a teacher, guys. I'm not someone who will just saying, just sharing some feelings here, right, and just going back to my home, right? I am a teacher, right? I need to see the response whether you are able to understand it or not. Otherwise, I'm teaching the walls only, right? So I need to see your response as well. Okay, right? Okay, yes, very good. Okay, great, great, great. Now, students, tell me one thing. Can you balance this? Can you have to answer me this thing. Can you balance this? Can you balance this reaction? You have no idea about what are the reagents. For balancing, you should know all the reactants, you should know all the products. But here, nothing like that is given to you. Here, they have given that you have a reactant. In the end, you have the formation of the product. And all of this carbon is converted to this particular compound. You only know this thing. So we can't balance the reaction. So we will apply POAC on carbon. So now we will learn how to apply POAC on carbon, right? Okay. So that's why we are applying. How can you balance, Siddhan? Tell me, how can you balance? Some reagents are there. Some reagents are there. I have no idea what are these reagents. If you know each and every reactant, you know each and every product, only then you can balance that reaction. Otherwise, you can't balance a reaction if you have no idea what are all the reactants and all the products. If you see here, they are saying a series of reagents. We have no idea what are the reagents, right? So that's where we are not able to, yes. Yes, okay. So that's why we are not able to balance it. So balancing is not possible. That's why we are applying POAC here. Now let me know in the chat box if you know that why I am applying POAC, right? Okay, why I am applying POAC. Now how to apply POAC? I'll just write it there again. That is K2CO3. K2CO3 give rise to, this is the compound that is K2ZN3, K2ZN3, this is FeCN, and this is 6 and this is 2. Okay, yes. Now, you have to apply POAC. Apply POAC on carbon. Now, why am I applying POAC only on carbon? Because they have given me for sure, the hint is given that so as to convert all of its carbon. That means apply POAC on carbon only. Because carbon, I am sure that the amount that you have taken here for carbon, full is converted to this thing. That means I am sure about carbon, so I'll apply POAC on carbon, right? So when you apply POAC on carbon, what you do, number of moles of reactant side is equals to number of moles of K2ZN3 FeCN6 twice. Now the amount of carbon that is here is fully converted to this particular thing. There is no byproduct which has carbon in it. That's why I can apply POAC here, right? So now if you see here how many carbons you have? You have 1 carbon. So it is multiplied by 1. Here, how many carbons you have? 6 into 2, you have 12 carbons. So you will multiply it with 12. And that is going to be your answer for after applying POAC, right? Now just solve it with the help of, now guys, what they asked you, they have given you this much of K2CO3. They have given you molecular weight of K2CO3, molecular weight of this. Now what I'll use, I'll just put it in a formula of mass by weight. So this is, I can say, the mass of K2CO3 divided by molecular weight of K2CO3. CO3 equals to 12 into mass of this compound. I am just writing this compound here, that is K2Zn3. Again and again I have to write it here, right? This is 2 divided by molar mass of this compound, that is K2Zn3 FeCN6 twice, right? That is there. Now we know the value of this. This is already given to you in the question, that is 27.6. This is 27.6. This is also given to you in the question, that is 138 is the molar weight. So I'll just write here 138. This is also, this is what they are asking you, right? And this is also given to you, that is given to be 698, right? So this is given to be 698. So now can you, what they asked you here, they asked you calculate the weight of product. And this is the product. So can you answer the weight of the product here? Easy, right? Can we use stoichiometry, ma'am? For stoichiometry, I told you that you need to balance this reaction. You can't balance this reaction, na? You can't balance. You need to have all the reactants and products for balancing. So if you can't balance the reaction, you can't use stoichiometry, right? For balancing, we need all the reactants, all the product, only then we can balance a reaction. And if you can balance only, then you can use stoichiometry. That's why in these kind of questions, this particular POAC application is what you will apply. Okay guys, everybody clear? Shall I move with the next question here? After solving, you will get the answer as 11.6 gram, right? Now, next question is, they have given you 0.32 mole of LiAlH4, right? This is LiAlH4. You know, whenever you will see application of POAC, you will see that you will never have all the reactants and products in the reaction. Some hint will be given to you, right? So this much of LiAlH4 in ether solution was placed in a flask, and this much of tert-butyl alcohol was added. Okay, 1 mole of tert-butyl alcohol was added. The product is this. Here you have tert-butyl alcohol. Okay, so tert-butyl alcohol, and here you have added, they are saying the product is coming out to be LiAlH C12H27O3. Find the weight of product if lithium is conserved. Can you see they are saying that lithium is conserved? Already a hint is given to you that you have to apply POAC here, right? Okay. Got it? That how you can apply POAC here. So let's apply POAC on lithium. POAC on lithium, everybody. So if you apply POAC on lithium, right, this is lithium and this is lithium. So what you will do, you will say number of moles of LiAlH4 is equals to number of moles of LiAlH C12H27O3. Here, number of atoms in a molecule is lithium is 1, so it will be multiplied by 1. This is lithium is also 1, so this will also be multiplied by 1, right? That means, can I say number of moles of this reactant is equals to number of moles of this reactant by applying POAC, right? Okay. Yes, everybody. Now, we are going to apply the POAC here, right? This is number of moles is equals to this number of moles here, right? Now, what they're saying, what is the weight of the product if lithium atoms are? Weight of the product means you have to find the weight of this thing here. You have to find the weight of this product here, right? So what you do, simple thing is you have to write the weight of reactant divided by molar mass of reactant is equals to weight of product divided by molar mass of product, right? In this way you can solve this. they have given you 0.3 mole of LiAlH4. That means this is given to be 0.32 mole. So this is also going to be 0.32 mole. So can I say that instead of writing this, can I say that 0.32 mole is equals to weight of this product divided by molar mass of product. So weight of product will be equals to 0.32 multiplied by molar mass of product. Molar mass of product will be, you can calculate it. See, lithium, addition of lithium, then aluminium, hydrogen, carbon, then oxygen, all of this you add, you will get the answer for the molar mass here. Right? Okay. Yes, everybody. How you can calculate the molar mass here? Molar mass of lithium plus aluminium plus 28 into hydrogen plus 12 into carbon plus 3 into oxygen. Right? Something 289 something you will get your answer of the molar mass. Right? When you solve this, then multiply it with 0.32 and you will get your answer for the product here. Right, everyone? Is that clear? Clear how we are applying POAC here. Right? Now, this is the next thing. Right, everybody? This is the next thing, that is now with the question, it might feel like this is a very tough question, ma'am. I can't do this, ma'am. Right? And all these things may occur in your mind, but in reality, it's not a tough question. Okay? If you know the funda of POAC, then it's an easy question only. Let's see this. In a gravimetric determination of phosphorus, an aqueous solution of dihydrogen phosphate is iron H2PO4 negative is treated with a mixture of ammonium and magnesium ions to precipitate magnesium ammonium phosphate. That is this. This is precipitated. Okay. In a determination of aqueous solution of dihydrogen phosphate. Okay. This is heated and decomposed to magnesium phosphate. That is this, which is weighed. A solution of this yielded this much of Mg2. That means this is converted to this, right? This decomposed to magnesium phosphate. Now, what is the weight of NaH2PO4 was present originally? Okay. Now, what you have to see here is that they are saying that in this an aqueous solution of dihydrogen phosphate, that is NaH2PO4, right, is treated with mixture of ammonium and magnesium ions to have this particular compound. This is heated to decompose to magnesium phosphate. That means in the end you have Mg2P2O7, right? A solution of this is yielded. That means a solution of this yielded this much of this. Now weight of this product is given to you. You just have to see that what is the reactant, what is the product. Okay, the overall, you see this statement, we know that the reactant is going to be NaH2PO4, right? The product is going to be this, right? Now, if you see this, weight of NaH2PO4 was present originally. Here the weight of this is they are asking you. Now guys, apply POAC on which thing? It's only possible on phosphorus. I can apply only on phosphorus because phosphorus is the most common thing here, right? Okay. Now, let's see if there is any hint, because it is determination of phosphorus. So that means all the phosphorus is converted, right? So the hint is already given that it is determination of phosphorus. That's why it is given like that. Okay. So now number of moles of NaH2PO4 equals to number of moles of Mg2P2O7, right? If you see how many phosphorus atoms here, you have just one phosphorus atom, so it will be multiplied by 1. Here you have 2 phosphorus atom, it will be multiplied by 2, right? Now if you solve this with the help of weight, right, we know that weight of, you can mark it like this also, this is weight of NaH2PO4 divided by molar mass of NaH2PO4 equals to 2 into Mg2P2O7. weight of Mg2P2O7 divided by molar mass of Mg2P2O7 multiplied by 2. Right? How many of you got this particular thing here? Right? Okay. Right? Now, let's see this. They have given you that this much of Mg2P2O7 is formed. Right? So, this is given to be 1.054. 1.054. Right? This you can calculate, this is what they have asked you. So easily by putting all the values of molar mass here, you can solve the value of weight of NaH2PO4. Right? Okay, everyone? Is that clear how to apply POC in these kind of situations? Right? Okay. So that's how to apply this, right? You just put in the weight here. The weight is 120. Here the weight is 222. Put in and you will get your answer for weight of the reactant that was there, right? Okay. That's it. That's it about POAC. Okay. Was it simple? Was it simple or difficult? Let me know in the chat box. Was it simple? Was it difficult? You find it difficult, right? The question was like this, right? In reality, it was such a simple question. If you skip these kind of topics for your exam, then definitely you are missing something, right? Okay, so that is my advice. Don't miss any topic, right? Some topics usually they scare you, but in reality, they are not difficult, right? Next topic for today is law of chemical equivalence, right? So let's understand the law of chemical equivalence, right, everybody? So if you talk about law of chemical equivalence, right, here also balancing is not needed. This is also a method in which you don't need to balance the equation to get the answer, right? So let's see what it is based on. Let's say I have given you an equation that is N2 plus H2 give rise to NH3. Now, can you say that 1 mole of N2 is equals to 1 mole of H2 is equals to 1 mole of NH3? No. Ma'am, why? Because the reaction is not balanced. If you balance this reaction, this is 3, this is 2. In the balanced reaction, we can say that 1 mole of N2 will react with 3 mole of H2 to give 2 mole of NH3. Right? But what if in the same situation you are not able to balance the reaction only? You don't know how to you don't have enough hints in the question. You don't know what is exactly I should do to balance the reaction, right? Maybe the reactants are not complete. Maybe they have just randomly given that this is reactant, this is product. Nothing is given how it is converted, right? So in these kind of reactions, when you can't balance the reaction, right? So what if they have just given you this thing, you can't balance the reaction. Then if you can't balance the reaction, let's say they have given you N2 give rise to NH3. Now you can't balance the reaction here, right? You have like one reactant, one product, you don't know which is what thing they have used. N2 give rise to NH3, that's it, what you know. Now moles in these cases, when you can't balance the reaction, you are not sure whether the moles are equal or the moles are not equal, you are not sure on that, right? But one thing that we are sure is that 1 gram equivalent of N2 is equals to 1 gram equivalent of NH3. That is law of chemical equivalence. That without balancing, you can say in that reaction that all the reactants will have same gram equivalent as compared to all the products, right? So that is law of chemical equivalence, which states that according to law of chemical equivalence, whenever two substances react, the equivalence of one will be equals to equivalence of other, and equivalence of any product will be equal to the reactant. Let me give you an example of that. For example, you have this particular unbalanced equation. This is not balanced. And in law of chemical equivalence, I am talking about unbalanced reactions only, right? Where you can't balance yourself, right? Now, here what you will see that here I can't say, because it is unbalanced reaction. We can't say moles of A is equals to moles of B is equals to moles of C is equals to moles of D. You can't write it. It may be, may not be. We don't know. We have no idea on that. But one thing for sure you can say from this law of chemical equivalence, that number of gram equivalents of A equals to number of gram equivalents of B equals to number of gram equivalents of C equals to number of gram equivalents of D. Right? Now you will ask me, ma'am, okay, we got you. But ma'am, what exactly is this gram equivalence that you are talking about? What is this gram equivalent? We know about moles. We have no idea on gram equivalence. So for that, we have to understand, I am talking about that moles will not be equal, but gram equivalents will be equal. But what exactly is gram equivalence? Right? For that, this slide is very, very, very important for you. Very, very, very important for you. Right? Okay. Right? Thank you. That's so sweet. Please, playlist of the videos, ma'am. It is hard to find, ma'am. Okay, done. I'll ask to make a playlist on that. Right? Now, let's see what is the formula of number of gram equivalents. These are the 4 formulas of number of gram equivalents, out of which this is the maximum that you will use. Right? Okay, let's do this. So, the first formula is number of gram equivalents is equals to given mass by equivalent mass. See, what is number of moles? Number of moles is given mass by molar mass, right? So when you're talking about gram equivalents, replace the molar mass with equivalent mass. Okay. So here, number of gram equivalents is given mass by equivalent mass. But ma'am, what is this equivalent mass, ma'am? See, equivalent mass is nothing but it is equivalent mass. Where should I write it? Equivalent mass is nothing. You can also write it as E. Is nothing but n factor into molar mass. Now, what is this n factor? Don't worry, I am coming up with a special lecture on n factor. What is n factor? Right now, I'll just show you with the help of examples that here n factor is this, here n factor is this. N factor is actually a valency factor. Today, I'll teach you some questions based on it, but it's not that law of equivalence is just this. We'll also study this in detail in redox reactions as well. Okay. So, some part we will study here, some part we'll study there. Right. Now, equivalent weight is equals to n into molecular weight. Right. N is the valency factor. Now we know that if you put this here, this will become given mass by molar mass into n factor, right? Okay. Wait a minute. Equivalent weight is equals to equivalent is equals to molar weight is equals to equivalent weight into n. My bad, right? That is that. Molecular weight is equals to equivalent weight into n factor. Okay. So if you put this here, right, given mass, I am representing it by W. This is W by E. So this will become W by E is nothing but molar mass into n factor. So this will become, this is nothing but number of moles. So this will become number of moles multiplied by n factor. This is n factor. Okay. This is n factor. So number of moles multiplied by n factor, that is your another formula, right? That is number of moles multiplied by n factor. Third is, if you solve it like this, number of gram equivalents is equals to volume of solution. See, simple thing is normality is equals to n factor into molarity. Or you can just simply write here, Normality, we know. If you multiply normality, what is normality? Normality is number of moles. Normality is number of moles divided by gram, or you can say it's not number of moles. Normality is number of gram equivalents. Number of gram equivalents divided by volume of solution. Right? That is normality. Right? Now, if you want to write it in terms of normality, if you multiply normality with volume, it will cancel out, and that number of gram equivalents will be equals to normality into volume. So this is also another formula. Then the last formula is, what is normality? Normality is molarity into n factor. So molarity into n factor multiplied by volume of solution is the fourth formula of number of gram equivalents. All the formulas are equally important for you, right? You will use this throughout your physical chemistry, right? In not thermodynamics, mostly in equilibrium, sometimes in also in electrochemistry, the last part of electrochemistry you use this, right? Then equilibrium, ionic equilibrium, chemical equilibrium, sometimes they ask you this thing, right? And in simple general, sometimes they fuse the question of these kind of n factor gram equivalents with some basic concepts of chemistry, mole concept or something like that, right? So that is important for you to have the relation between what exactly, how to calculate number of gram equivalents, right? Okay. Now, let's solve some questions on that and your lecture will be over, right? Calculate the number of equivalents in 1 mole of oxygen molecule, right? So calculate the number of equivalents in 1 mole of oxygen molecule. See, simple thing is, they have given you mole here, right? Oxygen molecule. So whenever you want to calculate the gram equivalent in terms of moles, tell me what is the formula? Number of moles multiplied by n factor. So can I say number of gram equivalents is equals to number of moles multiplied by n factor. Now what is n factor? This is number of moles, this is n factor. Number of moles is given to be 1. What is n factor? See, oxygen is -2. So for oxygen, valency is 2, right? So for O2, it will be 2 into 2, that is 4. So n factor is going to be 4. So n factor is nothing but it is valency factor, right? So right now you just understand this much. It is actually in so much detail in your syllabus, right? I'll teach you that, don't worry, right? So oxygen, we know that it has 8 is the atomic number. So 2 and 6, we know that it will gain 2 electrons to have complete electrons. So that's why valency factor is 2 for 1 oxygen atom. We have 2 oxygen atoms here. So valency factor will be 2 into 2, that is 4, right? So here answer is going to be 1 into 4, that is 4 gram equivalence. Equivalence is the answer here, right? Okay. Okay. What is not clear, you can let me know. If you're confused about how I calculated the n factor, that I'm telling you that I'll take a separate lecture on that. N factor is itself a very detailed topic. It will take us 1 hour to understand n factor. Right now, you just understand this thing, that n factor is actually valency factor, right? Oxygen has 2 valency, so 2 oxygen will have 4 valency, right? Okay. Now, next is your JEE Advanced 2020 question, that is, in a chemical reaction between stoichiometric quantities of KMnO4 and Ki, they are saying that you have KMnO4 and Ki, right? Now, weakly basic solution, in a weakly basic solution. So first thing is, this is from DNF block. See, that's why it's a JEE Advanced question. In JEE Advanced, they don't ask you questions on like simple way, right? 2 things they have fused here. One is DNF block reaction. Other is your law of chemical equivalence, right? So when you solve this, this is a very strong oxidizing agent. So they are saying it is a weakly basic solution. Now in weakly basic solution, this is converted to I2. In acidic solution, this is converted to IO3 negative, that is iodate ion. This you will study in class 12th DNF block, right? That's why it is a JEE Advanced question, okay? So here they have given that this is a weakly acidic solution, so it will be MnO2 and this is I2. Now ma'am, how I know the reaction? This is from DNF block, we know the reaction, okay? Now if they have given us weakly acidic solution, then things will be totally changed. This will change, that you will study in your DNF block, right? Now, next is, okay, what is the number of moles of 12 released for 4 moles of KMnO4? Okay, I2, acha, like 12, what is this? What is the number of moles of I2 released? They are saying number of moles of I2 released if 4 moles of KMnO4 are consumed. Right? Guys, you can solve it in various ways. Okay. Firstly, can I apply POAC here? Tell me. Can I apply POAC here? Right? Can I apply POAC? No, I can't apply POAC. Why can't you apply POAC? Who will tell me why can't I apply POAC? Why not POAC? You have to ask yourself these questions again and again. In the exam, they will not tell you, hey, you have to solve it with law of chemical equivalence, solve it with stoichiometry, solve it with limiting reagent, solve it with the POAC. They will not tell you that, right? So you have to use your brain. Like, why? Why? Yes, you can definitely use stoichiometry here. That is correct. Stoichiometry you can use here. You can use that, right? POAC can you use? No. POAC is applied when at least one atom should be common. Between this and this, there is no atom that is common. So how I can apply POAC? So POAC is not applied here. Stoichiometry you can apply here, right? But now I will solve it with law of chemical equivalence to make it easy for you, right? So if you see this, in this case, first you have to see in this particular way, right? What is the valency factor? See, here it is x plus x minus 4 is equals to 0. It is converting to plus 4. This is KMnO4. This is x minus 8 is equals to minus 1. So x is equals to 7. So this is nothing but this is plus 7, right? So plus 7 to plus 5. 5, 6, 7. That means 3 is the valency factor here. N factor is 3. Right? This you will study in redox reactions. If you are getting confused that, ma'am, how you are doing all these things, this is the topic of redox reactions. They have mixed so many things. It's a question of JEE Advanced. One thing is, you have to apply redox reaction to understand the N factor here. You have to apply DNF block to understand the reaction here. You have to apply some basic concepts of chemistry to apply stoichiometry or law of chemical equivalence. Right? Now, this oxidation state is plus 7, this is plus 4. So, for one manganese atom, change in valency is 7 minus 4, that is 3. Right? In this case, you have I negative, that is minus 1. This is 0. Right? So, here the change in valency will be minus, you can say minus 1, 0. So, that is going to be minus 1, 0. So, it is going to be 1. So, N factor is going to be 1. Okay. Now, can you see one thing here? Very important that we will learn in redox reactions. For here, manganese is 1 here as well. Manganese is 1 here as well. So, I am using 1. I am using for 1 manganese. This is for 1 manganese. This N factor is for 1 iodine atom. But here you have 2 iodine atom. For 2 iodine atom, right, we have N factor is equals to 2 into 1, that is 2. So, N factor for iodine will be 2 and N factor for manganese will be 1. N factor for manganese will be 3. Okay, this is what you have. Clear? Now you have to apply, once you know n factor here, what else, number of moles. Now you must feel that n factor is such a big deal, but it is actually very simple. When it is on your tips, it is simple, right? So now they are saying what is the number of moles of I2 released when 4 mole of this is required. Simple thing, right? We know that simply we can say this here. This is number of moles of KMNO4, right? So when you apply law of chemical equivalence, you can say 1 gram equivalence of KMNO4 is equals to 1 gram equivalence of I2, right? I'll just write it on the next page as well. So we don't have it. So I'll just write it here only. 1 gram equivalent of KMNO4 is equals to 1 gram, or you can say number of gram equivalents, number of gram equivalents of KMNO4 is equals to number of gram equivalents of I2. Okay. Number of gram equivalents has the formula number of moles. KMNO4 has how many moles? We have no idea. Number of moles of 4 moles of KMNO4. So number of moles are 4. N factor is 3. This is number of moles we don't know, but N factor is 2. So I can say number of moles of I2 is equals to 4 into 3 by 2. That is nothing but 6. So answer will be 6. Okay? Okay. Yes, everybody. That's how you can answer this, and you will get your answer here. This might feel that, okay, this is tough, but the calculation, it eases the calculations. That's why this is very important. Okay? Now, last question of today, right? Yes, this is the last question of today. That we will solve, and this is a very, very important question. Okay? This is a very, very important question. This will expand your, the rigidity that you have, that I'll solve with this only, This will expand that. 2 gram of metal when dissolved in HNO3. They are saying there is some metal that is dissolved in HNO3. Okay. Gets converted to nitrate salt. Now, nitrate salt, we know that nitrate is this. Metal, let's say metal has I am assuming that metal has valency N. Okay. So with N valency, it will be MnO3N. Okay, you can take any valency. I am taking N as the valency. Right? I am taking N as valency of metal. Okay. Now, after this, they are saying the nitrate was then precipitated to form, this nitrate is then precipitated to form metal chloride. Now, metal is this is chloride. Chloride is -1, this is N positive. After cross multiplication, you will have M, this is 1, this is N. So, this is what you will have as the answer, right? Now, they are saying equivalent mass of metal can be. Now, you don't know what is that metal. You don't know what is the valency of that metal. You have to find. Yes? Okay. Very good. Ma'am, can you explain? Firstly, I'll explain this question, then I'll come back to that question. Okay? Yes? Achha, do you want me to go there first? Achha, ma'am, I don't know how you solved. See, students, what we did here. See, if you have never gone through redox reactions, you have never gone through N factor, then skip this question, okay? Then you can skip this question, right? Then once you learn N factor, this will become very easy, right? I can't teach you N factor in just 2 minutes. It's the work of 1 hour, right? If you're confused between this thing that I'll teach you, see, by some method that we do in redox reaction, N factor of this is coming out to be 3. This is coming out to be 2, right? Now, we know that law of gram equivalent says that all the reactants and all the products, gram equivalents will be same. Here, they are asking me to compare KMNO4 and I2. So, I'll equate the gram equivalents. Gram equivalents of KMNO4 is equals to I2. Now, what is gram equivalents? In terms of moles, it is number of moles multiplied by valency. Number of moles multiplied by valency. So, this is the This is the number of moles of KMnO4, right? This is valency factor of KMnO4. This is valency factor of I2, and this is number of moles of I2. By this, I solved this question. Okay, right? Yes, if you're in 9th class, then you can't understand. Then you will not be able to understand this, right? For that, you have to go through the redox reaction. Only then you'll be able to understand this. Okay. Yes, everybody. Clear? Now, let's do this question here. Right? Okay. Shall we do this question? The last question of today. Right? Let's do this. 2 gram of metal when dissolved in HNO3 gets converted to nitrate salt. Right? They are saying there is some metal. Right? 2 gram of this metal you take. How much gram of this metal you take? 2 gram of this metal you take. Right? That is dissolved in HNO3 solution to get converted to nitrate salt. This is nitrate salt. So now I am taking the valency of metal as N positive. Right? Metal is electropositive, so that's why I have taken valency as N positive. It will be converted to a cation only because it is forming with a nitrate ion. So this must be a cation. That means it must be Mn. This will be M, valency is N, right? And this will be NO3 negative. After cross multiplication, you will get this. This also is M raised to power N positive. This is Cl negative. After cross multiplication, you got this. Right? Let me know if this reaction you are able to understand. Now they are saying that this much of metal chloride is formed. That means metal chloride formed is 2.66 grams. This is also given to you. This is also given to you. Now they are asking you equivalent mass. So can I apply law of equivalence here? Because see, they have given me like a relation between these two things. That means given things are this and this only. So what I will do, I will try to apply law of chemical equivalence here, right? See law of chemical equivalence, how to apply that, right? Okay, sure. Wait a minute. Yes. Okay, now let's see how to apply that. We'll say number of gram equivalents of M is equals to number of gram equivalent of MClN, right? Because see, we know that number of moles we can't equate like that, but number of gram equivalents we can equate like that. That is the benefit of gram equivalents. We can equate this with this without even balancing. We can't balance this reaction. We don't know what is this M. How can we balance this reaction? So without balancing, we can apply this gram equivalent concept here, right? Okay, right? Now, let's see this. After this, what we are going to do? What is the formula here for gram equivalents in terms of mass? That will be given mass by equivalent mass. We know that this is another formula. If you see this now, the formula that I can apply for this is, if you start applying this formula, this will not be applicable because N factor you don't know. But you can apply this formula here, given mass by equivalent mass, because they are asking you equivalent mass only. So you should apply the first formula here. So what I'll do, I'll apply the first formula here. That is 2 divided by equivalent weight of, let's say metal, I have taken it as E, equivalent weight. So E is equivalent weight of metal, right? Given by equivalent weight is equals to, given is what? What is given to you? 2.66 by equivalent weight. See, here equivalent weight of MCN6 will be, this will be equivalent weight of metal plus equivalent weight of Cl. Cl is just one negative there. That means there is just one, that means Cn is just one negative there. So that means valency is 1. So mass of, see here, if you have to write down the equivalent weight of chlorine, right? That will be molecular weight Molecular weight is 35.5 multiplied by n factor, because it is Cl negative. Just one negative is there. That means n factor is 1 here, right? So multiplied with 1, it will be 35.5, right? So you can just put it here, equivalent weight plus 35.5. Now you can solve it and you will get your answer, right? But just see, one thing you should be clear, that n factor, those who don't even know what is n factor, for them I am writing this. N factor is, if you have an ion, it is equal to charge on ion. Charge on ion. Right? If you have an ion, because till now I have only solved questions where ions are involved. Right? So in this case, chlorine is Cl negative. So the charge is 1. That's why the n factor for chlorine is 1. Molecular weight for chlorine is, we all know, 35.5. So equivalent weight of chlorine will be 35.5. So that's why you will put it here. That is E plus 35.5. E is the equivalent weight of this metal. E is the equivalent weight of this metal here, right? And C 35.5 is the equivalent weight of chlorine here, right? Okay. That's it. That was today's class. Okay. Clear, everyone? Here also, if you move back, no? If here also, if you move back, then ma'am, how you solved it? I solved the oxidation number. I solved the oxidation number. After that, I saw how much is the change, how many electrons it is gaining, right? It is gaining 3 electrons. Change is 7 minus 5, that is 3. Sorry, 7 minus 4, that is 3. And here it is 1 minus 0, that is 1 is the change. So for 1 manganese, the change is 3. For 1 iodine, the change is 1. But here the iodine is 2, so here change will be 2. That's why here n factor I have written 2, here n factor I have written 3. Number of moles were given to me. Okay, clear? So that was about law of chemical equivalence, right? I know you find it difficult just because of the n factor, right? Don't worry, we are going to do a separate lecture on n factor, right? That is in our syllabus and that is very, very important, right? So now let us see this question here. This is your first question. Write the expression of n factor in terms of gram equivalents, in terms of number of moles, in terms of volume. That is the first question for your homework. Then the second question is, what amount of CO will be produced by 1 gram of calcium? See, here I'll also give you a hint. See, you have calcium and they are saying CaO is formed, right? Just remember that n factor of calcium. Calcium also always exists in Ca2 positive, so n factor is 2, right? They are saying that 1 gram of calcium is there. What is the amount of CaO that is formed, right? So this mass, I am taking it as W. What you have to apply here is, given mass, you can say number of moles, you can apply that gram equivalents of calcium is equals to CaO. Then we know that calcium is number of moles of calcium multiplied by n factor of calcium, right? This is number of moles of CaO. This is n factor of CaO, right? This number of moles will become weight of calcium by molar mass of calcium. This is also weight of calcium by molar mass of calcium, right? Now, most of it I have already told you. Let us see who can answer this, right? Most of it I have already told you what will be there, right? Now, let us see how many of you will be able to answer the second question. First, I know all of you will be able to. Second, let's see how many of you at least try to answer this. Okay, for time management, for solving JEE Advanced questions for time management. Okay, Rama Raju, I'll definitely make that. You can also write it in the comment section so that I can remember that I have to make this video, right? Okay, yes. Okay then students, that's it for today, and this is our official Telegram channel where you can go and subscribe, because all the updates regarding your live classes are there on this channel. And students, if you see this here, we have for all the JEE 2027 aspirants, we have 20,000 off that is going on our JEE Pro batch. In this batch, basically, it's like an offline feeling only, because in this batch, even teachers, we can see you, we can talk to you, right? And you know what's the best part? That there will be someone who is already looking at you while you are in the class, right? Like in the offline center, the teachers are there who see that whether you are focusing in the class or not. There will be no distraction. If you are moving here and there, you are getting distracted again and again, the teacher will point it out to you, because there will be someone else who is looking at you 24, like whenever you are in the class. Then you also have doubt solving 24/7. That means you are solving something and you have doubt there. Then ma'am, what to do? Now, when you have any doubt, you can just go to the app, you can video call a teacher, you can ask your doubts, be it 2 a.m., be it 2 p.m., doesn't matter. It is available 24/7. Right? So these are the two most important things that are there in the Pro batch, right? Because there is no distraction. It's like you are sitting in your home, but you are in an offline center of the teacher only, because the teachers are also able to see you. In one batch, the students are very limited in the class. The reason is why we keep students in a limited stock in one batch, so that every single student we can give attention to every single student. Because if you want to get a good rank, definitely you need proper attention, proper guidance, personalized attention of the teacher that is there in the batch, that is Pro batch. And if you ask, ma'am, is this there for JEE 2026 aspirants as well? Definitely it is there for JEE 2026 aspirant as well. That is 1 year course, right? You can see this here, right? But in this, it is 1 year, right? In 2027, it will be 2 years course, right? Here you have for 1 year course, you have 10,000 off, and for 2 years course, you have 20,000 off, right? Okay, yes. Will you teach electrochemistry? Yes, I'll teach electrochemistry, right? I have already started it, right? You can go and check out in the live section. Okay, students, then bye-bye. Take care. See you all in the next class. Bye-bye.